What's up, my fellow calculus pals, or as I like to call you, my calc pals? Today we're going to be talking about some sort of rates, specifically of the related assortment. So if you look here at the example problem, we have a square, all sides are equal. And the question is asking, how fast is the area increasing when the sides are 3 feet long and they increase at a rate of 2 feet per minute? So if we're going to figure this out, we have to consider the formula for the area of the square. So the area of the square is going to be x squared, because it's just going to be x times x, length times width. So yeah. And so then, since we're relating the sides and the area, we are going to need to take the derivative of this to get the rate of the area. So we're going to go ahead and get dA over dt equals 2x dt over dt, right? So dt over dt is basically, sorry, not dt over dt, I meant dx over dt. So dx over dt is basically going to be the rate of change of the sides, while dA over dt is the rate of change of the area, which is what we're looking for. So now we have all this info, so we're going to want to plug that in to get the answer to the question. So when the sides are 3 feet long, they're increasing at a rate of 2 feet per minute. So that's going to look like we got that from there. So then we just multiply that out. 2 times 3 is 6, times 2 equals 12. So the rate at which the area is increasing at this instantaneous point is going to be 12 feet squared per minute. Yep. Or feet. But basically, 12 is the answer that we're looking for. Yep. What is up, my calc pals? We are going to be doing some more related rates, R and R, rest and relaxation. Specifically on this circle, got a radius of R and an area of A. So we're going to want to relate these two variables, d of A over d of t and dr over dt. So let's get this bread. So first things first, got to write out the equation. So I hope we all know by now that the equation of a circle is A equals pi r squared for the area, So then we're going to have to do some implicit diff. Way we're going to do that? Well, actually, I take it back. Well, okay, anyway, we're just going to do some differentiation here to get dA over dt. So let's take some derivatives. dA over dt equals 2 pi r dr over dt. Wowie. So, all right, so that's that. Yep, anyway. So, let's say that at a certain instant, the radius is 5 centimeters. That's an R. And it is increasing at rate of 2 centimeters per second. So let's figure out how fast the area is increasing at this instant. So how fast area increase? Question mark. Okay. How do we do that? Okay, so we got that the radius equals 5, and it's increasing at a rate of 2 centimeters per second. The radius is. So basically, that means dr over dt equals 2 and r equals 5. So let's plug it in to get this hacking answer. All right, 5 times 2, 10, times 2, 20, 20 pi. All right, 20 pi. That's going to be the answer to that problem. Wow, love being a calculus genius.
All right, next problem.
Let's go. Alright, what's up, Calc Pals? Let's talk some more related rates. So, we are not just limited to the circle either. We also have the iconic rectangle. As you can see, that is a right angle right there. So, let's just say we have side lengths of x and y and a diagonal length of L. That's an L, cursive L, by the way, so you can tell it apart from the x and y. Anyway, so first things first, you got to write out the equation that relates all of these different things. So, what do we have? Oh, you know what this looks like? This kind of looks like two right triangles. Oh my god, that's because it is. Okay, so if that's the case, then we can say x squared plus y squared equals, wait for it, L squared. Wowers, okay. That is absolutely insane. So, what if we wanted to relate the rates of change of these if they all vary together, you know? So, we're going to have to do some differentiation. So, we're going to end up with 2x times dx over dt plus 2y dy over dt equals 2L dL over dt. Easy, okay. All right, so that is the thing that relates the rates. So now suppose that x is increasing at 1.5 feet per second, y is decreasing at 1/4 feet per second, 1/4 feet per second. X equals 3 and y equals 4. What if we wanted to figure out, well, why don't we figure out how fast the size of the diagonal is changing? So we have to figure out what unit that is. So the full size of the diagonal changing. So we're going to need the rate with all this info. So we're looking for dl over dt. Luckily enough, we already have a formula for that stuff. So let's just go ahead and start plugging stuff in. So 2 times 1/2 dx over dt. Oh, sorry, no. This should be 3. Because this is just x, not dx over dt. Times the 1/2 plus 2y equals 4. dy over dt, that's going to be negative. Notice that decreasing. It's going to be negative 1/4 times negative 1/4 right there equals 2 length of the diagonal. So we're actually going to have to figure out the length of the diagonal. Luckily, we already know that x is 3 and y is 4, so that's just going to be a 3, 4, 5 right triangle. So L is going to be 5. And quick tip, side note, for those of you who don't know, well, actually, sorry, this should be a triangle. So the 3, 4, 5 right triangle, this is the most common Pythagorean triple. It just means that if you have a side length of 3 and a side length of 4, the hypotenuse is going to be 5. That's just simple math. Okay, anyway, back to the topic. Now it's just dl over dt, which is what we're solving for. Let's get rid of this because that's in the way. Okay, now time to do some solving. So 2 times 3 is 6, times 1/2 is 3, plus 8 times negative 1/4, so that's going to be negative 2, so 3 minus 2 is 1, equals 2 times 5, which is 10 dl over dt. Then, let's do that quick, divided by 10, dl over dt equals 1/10. Bang. So we know that it's increasing at that time. Bang, 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 bang. Let's go, smiley face. Okay, Calc Pals, let's talk business. So let's say that we have natural log of 1 plus y equals 1/2 x squared plus 5. We want to find the derivative of this. And let me just put the camera there for a second so I can... Okay, now that my marker is freshly uncapped, we can tackle this problem. So we're going to have to do some implicit diff, it looks like. So if you guys didn't know this, basically, I'll just write it out right here. So yeah, that's just a handy thing to know. Oh, and look, what do we have here? We have something quite similar, so. Really I didn't mean this, I meant that. Right, so derivative of that. Okay, so basically we're just gonna take the derivative of everything here, so derivative of this is gonna be 1 over y plus 1, because derivative of this is just 1, and then this is like the thing, so yep, that is the derivative of this side. Except we almost forgot the critical thing, dy over dx, can't drop that, equals, we need to take a derivative here, so 2 times 1/2, we're using power rule, 2 times 1/2 is 1, 1x, that's just going to be x, yep. Alright, and so we're looking for dy over dx, so let us just multiply this times y plus 1, cancels that out, it's just 1, doesn't matter, so then we have y plus 1, so dy over dx equals x times y plus 1, bang, easy call.